Identify the asymptotes and graph. We're looking for two types of asymptotes. We're looking for vertical asymptotes and we're looking for horizontal asymptotes. Okay? Now, the vertical asymptote is going to happen at the number that makes my denominator here equal to 0. Now, if I were to plug in -1 for x, -1 would make the bottom here equal to 0 because I would get 4 over -1, and that's undefined. So my vertical asymptote is x equals -1. The horizontal asymptote exists at the number that's being added to the whole thing because that tells me the shift up or down. Whenever I have like a nice looking rational function like this, okay, it's supposed to level out at the zeros at the x-axis. But by adding 1 on the outside, that shifts everything up 1. So y equals 1 is going to be my horizontal asymptote. Now, if I want to graph, I have to remind myself that rational functions are going to look one of two ways. It's either going to look like that, or it's going to look like that. Oh boy, I'm going to screw that up. There we go, much better. Ignore that little line right there. And maybe by erasing it, it'll help me ignore that little line. Look at that, magic. All right, so I'm thinking, all right, well, how can I figure out which one is which, and how can I be a little bit more specific with my graph? Well, let's find ourselves our x-intercept, which is kind of frustrating to do, but that's all right, and our y-intercept. By doing that, we'll be able to put 2 points on the graph and figure out which one of these guys we're dealing with. In order to find the x-intercept, you're going to substitute f of x with 0 and solve. So not the prettiest looking thing in the world at all, but that's okay. If I subtract 1 from both sides, I'm going to have -1 equals -4 over x plus 1. If I multiply both sides by x plus 1, I got a little bit of distributive property action going on here. You cross out, I have -x minus 1 equals -4. Let's add 1 to both sides. I'm not really showing my work here because I don't have the space, so add 1 to both sides gets me -3. And if -x is -3, then positive x is positive 3. So that's my x-intercept. My x-intercept is going to happen at x equals positive 3. Okay, not so bad. Not good either, but not so bad. My y-intercept is a whole lot more pleasant to figure out. Let's substitute f of x with y because it just looks prettier. In order to find my y-intercept, you're going to replace x with 0, so -4 over 0 plus 1 plus 1. So that becomes -4 over 1, which is just -4 plus 1. And y is going to equal -3. So that's going to be my y-intercept. So I have 2 points here. I have x equals 3, so you happen. And I have y equals -3, so you happen. Also, I have a vertical asymptote living at x equals -1. Okay, let me use a little nicer line. There we go. So, okay, nice vertical line going through -1. I have a horizontal asymptote at y equals +1. So you go through here. And now I have a good idea of which function I'm going to deal with. Okay, since my line, my curve has to go through these 2 points, it's going to look like this option right here. So not looking for perfection, just looking for accuracy. I'm going to use my asymptotes as a guide because things start to level out at my asymptotes. Okay, and I'm going to use my asymptotes as a guide right there. And then I'm just going to try to draw something very similar over here. Okay, you could use points to plug in. That's okay. Here I'm not looking for perfection. I'm looking for accuracy, right? And so this is going to be the graph of the rational function. So pretty crazy stuff.